Hello, I wanted to start a new task today because the partial stickiness is done for now, although perhaps I will revisit it at some point. But I wanted to do a new feature. This is the idea that some floors in the game, for example, let me see, imagine that there is lava above this rock, no? So if you simply move like this, you lose because you are burned by the lava. So you must use the crates or the rocks to pass above the lava, and if you want to, you can push boxes over the lava, but not grab them, because you could also be burned this position. So to implement this, let me check. We obviously need a way to control the generator. To tell the generator to use to put the lava in the level. So we need two more parameters here. Let me add. We can add here the min and max parameters for the lava. So this is starting to add more and more parameters here. Let me see: size, density, radius, crates, lava glue density. Okay. Suppose we could say 0 as a minimum and 3 as a maximum. Obviously, we are not using the variables yet, but I wanted to test the parsing of the command line. Okay. Now we need, in the struct that represents the puzzle, we must have, let's use, I was meaning to optimize here a bit using another data structure, because to check if a position is occupied, we are using a list of points for the spaces, and we will use a list of points for the lava here, but obviously searching, I have a function that finds a position in an array of points, or a crate in an array of crates, like this. But this is a bit ugly and slow for big levels, so perhaps I will, in the future, I will make a video about optimizations, but not today. Let's do first the simple thing that works, and then optimize it. Okay, now in the constructor of the puzzle, we must after we set all the spaces, we calculate the doors, and the position of the player, and we fall. We make the things fall. After this, we could or better yet, after the controls of size and length. Yeah. After we determine that the level is valid, yeah. Let's determine uniform is a function that from the D library that returns random values with a uniform distribution, and by default is closed at the beginning and open at the end. Okay. While we have less lavas than required, let me see. Not always the levels could. This is tricky because the levels could have less space for lava than the maximum required or specified. Yeah, I will use the tries logic that I use here. Yeah. Okay. Let's select a random position. Let me check. Yeah. Let me use this. Here we are selecting space at random from the spaces available, and we must cast the position downwards. So imagine that we are selecting this space here for the lava. Obviously we don't want to put the lava here, but we want to make it fall to here. No? Okay. So we will decrement the position vertically while yeah, we decrement the position while the position exists in the spaces array, and if the position no longer exists, we increment it again. Okay. Yes. And we check if we find the position in the lava array, we continue the loop, the loop, and if not, we append the position and reset the tries. We must control For example, let's use that. Okay. Now, how do we debug this? Yeah, we must modify the toString function to put, instead of a wall, a lava. Sorry, I'm doing something wrong. We must not increment the position. We will use, let me show you. For example, if we select this position for the lava randomly, we make it fall and the lava will be put here. Yeah, instead of here, because we need to, we will use the same coordinate as the wall. Okay. Yeah. Now, in the toString function, we will put a new condition here. Let's use a symbol, an interesting symbol for the lava. We could use the spike one. Yeah, let's see. Check for the player position, the entry point, the doors. I wonder if possible doors. No, possible doors cannot be lava because they are below. Yeah, they are always. Let me show you. The positions for possible doors are never below a space, so they never could become lava because for example, this position or this position cannot be lava. Sorry, no, this is the example. This cannot be lava because it's not a space. Yeah, okay. Okay, let's check if the let's remove. We are putting the information. Let me check again the order of the parameters. Yeah. Okay. Let's make some bigger levels. We have errors. Yeah. 26. We put a break here. Why did? Okay, I sometimes I type very bad code. Okay, we are generating levels with lava, but obviously not using it yet. Let's see. Okay, let's search for lava. This is a wall. This is a wall below space. Wall below space. Yeah, it seems to be valid. There are some situations. Okay. Obviously, we must add lava to the parser of the game, because obviously it's not recognizing the symbols. But yeah, here there is lava. Here it is. Interesting. Ah, no, this is not lava. This is lava. Okay. Okay, obviously we must let's make a special wall asset, which for now will be the same, but red, for example. Very albedo. Let's make it very red. Yeah. And in the load level function, let's make this is no, let's make this logic for now. Yeah. Ah, interesting. We something that Godot uses. If you use an external resource for the materials, when you change it, you change all the assets that make that uses that material. So let's revert this material. So now there are no holes because all the lava is represented with the same asset. Okay, let's make a new material for the lava. This one, we change the color. Let's make it a bit less violent. We could make it emit light, but let's make it use this material. Okay. We are not distinguishing wall prefab. If let's use sorry, let's make a new prefab for the new prefab argument here, and lava prefab. This one. Okay. Perfect. Now we are loading the lava tiles correctly. Yeah, we must put a bit more care about the positioning, because there are some positions like this one that are not very sensible. Like this one, because obviously if we make lava more believable, the lava should flow downwards, so it's not very believable that could be a lava block here. We should check the two neighbors and only make lava if there are two non-spaces to the left and the right, no? Yeah, let's add that let's remove the levels and add that control to the, here it is. Okay, we make the position full, and here we must check. This check is fine, but we must check pos plus left in spaces, and pos plus right okay. If no, this condition is yeah, this is an OR, because we don't want spaces to the left or the right. Okay. Nor below, because yeah, could check only below. Now that I think of it, let's check only below and see what happens. Let's check only below. Let's generate a good chunk of levels. Okay. Below. This is no good, because yeah, we should check spaces also, I think, because this is not very yeah, let's check also the spaces. Let's put this here. Yeah, so let's use all the checks to the left, to the right, and downwards. Okay. Let's remove all the levels and make a new batch. As you see, one of the I think the generator fell into an infinite loop here, unless yeah, it fell into an infinite loop because I made a mistake. Surely. Let me see. Ah, if I don't increment the control, it's useless, obviously. Okay, I wonder if I should check. Yeah, I think that's enough. Let's generate again. Yeah, obviously with this more astringent condition, there were less valid tries. So now it's working. It's working. Okay, let's check. They are well behaved. Yeah, interesting. Yeah, I think it's working. Nice. Okay, I think for now I will stop here, but obviously the logic of the game is not using the lava yet, and nor is the generator, because the valid moves must take lava into account. So I think I will leave that as a cliffhanger for next session. It's a nice cliffhanger. What to do with the lava? Thanks for watching. As always, if you enjoy the video, click like and share the channel or at least this playlist with the people that you think would enjoy this kind of things. Thanks.